For the urinary system, number 1, trace the flow of plasma or blood through the arteries, nephron, and veins. Renal arteries, segmental arteries, interlobal artery, arcuate artery, interlobular artery, afferent arterioles, glomerular capillaries, efferent arterioles or interlobular capillaries, interlobular vein, arcuate vein, interlobar vein, segmental vein, and renal vein. Number 2. What are the 3 steps or processes of urine formation? Where do they occur, and what materials are reabsorbed or secreted into the urine? Number 1. Glomerular filtration. Water and solutes are forced from blood to nephron. Step 2. Tubular reabsorption. Water, glucose, ions, and other useful substances return from the nephron to the blood. Step 3. Tubular secretion. Toxic substances and H+ ions are secreted into the nephron to be eliminated as urine. Number 3. What are the 3 mechanisms that our bodies use in maintaining blood pH? And what structures are involved and how do they work? For 1. Buffer systems include bicarbonate ion and carbonic acid system, proteins, hemoglobin, and phosphate. Second, pulmonary regulation. In this mechanism, the lungs regulate the amount of carbon dioxide. It works in ranges since it has 2 kinds of receptors, peripheral and central receptors. Peripheral receptors respond to changes in H+. The central receptors, however, respond to the changes in CO2. This mechanism is fast, usually effective within minutes to hours. Third, renal regulation. In renal regulation, kidneys excrete hydrogen ions and bicarbonate and secrete ammonia that help maintain blood plasma pH within a normal range. HCO3 found in the filtrate are essential to the bicarbonate buffer system, yet the cells of the tubule are not permeable to bicarbonate ions. The main goal of renal regulation is to take HCO3 so that it could be reabsorbed back to the blood. In contrast to pulmonary regulation, which is deemed effective within minutes when compensating for pH changes, the renal compensation is slow, therefore taking days to respond to pH disturbances. What are the implications of acidosis or alkalosis? Increase in acidity is termed as acidosis. Acidosis can be respiratory or metabolic. Respiratory acidosis results from inadequate function of the lungs, which causes the accumulation of arterial carbon dioxide. Metabolic acidosis, however, is characterized by a decrease in plasma bicarbonate. It results from excessive production of metabolic acids, decreased ability of the kidneys to excrete acids, ingestion of acids, or loss of alkali. On the other hand, increase in alkalinity is called alkalosis. Alkalosis can also be either respiratory or metabolic. Respiratory alkalosis results to excessive exhalation of carbon dioxide caused by increased ventilation. Metabolic alkalosis, however, can result from excess loss of acids through the kidneys or gastrointestinal tract, bicarbonate retention, or ingestion of alkali. Thank you for listening. This is Rachel Libradilla of Black M1.